This
right?
conference will now be recorded.
Right beneath it, there is an interface symbol. So when you create interface, it will create. So then it would automatically add this signature, public interface name. Okay, so then you can add. Okay, or you can also type just like public class interface name, just like public class name. Okay, so what is you're going to do in the interface practically? So you can create some variables, all right, constants or final variables, and some abstract methods. So what are the abstract methods? The methods which have only declarations but don't know definitions. What does it mean? So definition means you already know. If this is the function, so I would create definition, what the add would do. We already did that before, right? In this case, in the interface, I would just leave it with a signature only. That means only declaration, public add. I did not specify what add is, correct? So I did not do something like this, correct? Integer a, comma, integer b. So then I want to add, then simply I will add integer c is equal to a plus b. Then I can sys out or return integer. So it doesn't matter, right? But it is not allowed since abstract method should not have a definition of it. So I just declare it and leave it undefined. So that's abstract method. Okay, and semicolon. So access modifier, return type, void or any return type, and the method name and bracket open bracket close. If you have any arguments, you can put arguments, or if you don't have arguments, you can leave it empty. So I want to create 4 methods: add, subtract, click, and division. Okay, so division takes 2 parameters, integer. Okay, now how can I define them? Where can I define them, and where should we define them? So to define, you have to implement this interface. The interface name is interface main calc. So I created another class. Okay, so right above it, interface implement scientific calc. Let's say this interface name is interface main calc. Okay, so calculator, and regular class. Okay, this is a regular class, and make it implement this interface. Okay, so implements is the keyword. Just like you inherit the parent class, child class, make the child class inherit the parent class using one keyword. What is that? In the last class we have seen, day before yesterday.
Extend.
Extends, exactly. So likewise, I mean, both are different concepts. I'm just reminding you. So if you want to implement the interface, you just use a keyword implement. So this has to be regular class though, not an interface. This is an interface. Okay, so let me jump back to that public interface. This, then in the interface, what I would create, I would only create the abstract methods. What are those? Methods with only declarations, no definitions. Okay, so you don't even open the bracket, open bracket close, just end it with the semicolon. That's all. That's all. Okay, now what do you mean by implementing? So implementing is providing the definition itself. That means you define actually whatever is left undefined in the interface, you actually define them according to your requirements. Okay, so we will see practical example of this. So there is a practical aspect for this. So I created one variable and 4 methods, right? 4 abstract methods. X is equal to 10 is one variable, and add, subtract, click, and division is are the 4 methods in the interface. Now I can change the value. Okay, x1, was it x or x1? Okay, x is equal to 10. Okay, so I create one more variable, so it doesn't matter. Okay, and add was a function inside this interface. Then if I want to define add, I would simply do this. Okay, signature of add, open the brackets and close the bracket like this, and whatever is goes inside, that is the definition, that is the stuff. Okay, so in this case I just want to print, okay, instead of providing actual definition of add. Okay, so let's see, just for the demo purpose I'll just put a sysout, and this is scientific calculate add. Okay, so just to indicate that this is actually being called from this interface implement scientific calc, not from interface main calc. So just to indicate that. So if you want, we can actually put this is scientific calc implemented. Okay, so that we will know it is actually implemented. Okay, so let's actually run and see. Let it build. Okay. Okay, so likewise, I implemented sub also. Sub was also, it was open, undefined. So system out.println, it will print this sub, and multiplication and division. Division also I'll just print x by y just for the sake of, if you want we can add, this is scientific calc div. This is div. All right. Okay, so I would put the main function in the same class because I don't want to create another task, because this is already in the task. Okay, so you can create one more class if you want to, just to call these from there. Okay, so to avoid that, I'll put main in the same class. Okay, now I create two instances of two classes, one in interface, one is a class interface implement scientific class. This object name is cal, let's say, and interface main calc. Okay, so that was the interface. Okay, but the instantiation is little different, the way we have seen in the last class, right? The parent child. So I am creating the instance of main class for the scientific class, which is implementing the main class. So just remember, this is cal, this is cal2. Okay, so you can do others also, but which which will definitely be illegal operations. That means they will throw the compile time errors. Okay, so right away you will get errors, so they are not possible. So I commented, you can uncomment and see. Okay, so using cal, scientific cal, I called add sub mul. Okay, so obviously it will call these implemented, and then they will print something to the console. So we will immediately know they are being called from the this one, scientific calculator. Okay, so now let's see what happens if I call these methods using cal2 object. Okay, which is an instance of main calc with new for the new instance of the scientific calc, which is actually implementing the main calc. So add and sub are called. Okay, let's see. Remaining all are either illegal operations or just demo purpose I created. So I'll explain those later. So let me run them and see. Okay. Okay, so first time my system throws error. Your system may not throw error. I'll just run it again. Okay, so let's have a look at this. The first call is cal.add, right? Cal.add. Let's see where it jumps to. Cal.add obviously jumps to the definition part of it, which is actually there in the scientific cal, and whatever I wanted to print, it is printing right here, right? And similarly, sub multiplication also. So if you want, we can see sub, this is scientific cal, sub, this is scientific cal. So, and mul also same thing. So till this portion, it's straightforward. Now let's see what is being called using this. So in the inheritance portion, like the same thing happens, it will also call whatever is being implemented, and it is oh sorry, whatever is being implemented, it is called, but it is going to the interface, but it will actually call this. So by sys out, so don't control click in this case, you might get the diverted. So cal2 add cal2 sub also calls the same thing, so irrespective of whether you jump, so do not control click. So all you have to understand is whatever you implement, it will call. Okay, so finally let's see the variable. What happens with the methods we have seen. What happens to the variable? There is a variable x we have created and whose value is 10, right? So that value will be printed. If you this is implemented in which class? It is implemented in interface scientific demo, right? So when you call using either cal or cal2, it will always call the implemented function, not the abstract function. So even though if you control click, it will jump to it, but do not do. So it will directly call that one. Okay. To
So
illustrate, I
Sangam,
call.
I have a question.
Yeah, go ahead. Go ahead.
So we making the class only in test, or we have to make the class for the library also? I'm confused right now.
You mean you want to create the class in library or not the test?
Yeah, we have to make the class in library, or no? We just doing
Doesn't
the
matter.
test.
You can create this in the library also, doesn't matter. I created just inside. If you create this in the library, then
Yeah.
you have to you have to add the package declaration. Okay, so let's do that if you want.
Okay.
In calc, so let me move it. But if you want to move, you have to actually move properly. So let's see if we can move. It is not a reusable function, the class with the reusable functions. It's just an interface, just to give you a demo. But I will explain you the more practical purpose. But if we want this to be inside, where is move? Okay, there is move. Let's see. Okay, so it will show you the package names. Then I want to move to library. Then okay. So if you properly move, you have to move it with factor move. Okay, so hopefully no errors. That means we are good. Okay, fine. So it moved properly, no issues. Okay, so interface is in Java library and the class implementing is in the test. So we are good. Okay, so that's not. Oh, we are not good. So let's see what. Unless and until I go to the class, I don't know what error it would throw. So I'm just hovering over it. Let's see what could be the issue. Issue could be the path. So let's see what the Eclipse suggests. Let's go with that suggestion. Okay, so you just have to import, that's all. So let's import that. Always do the same thing. If you get an error, just go for the session and read the suggestions. Since I have moved the class to different package, all you have to do is just import that package. So the package name would be import interface. Oh, so we have moved it to, wait, we have moved it to library, right? So okay, let me import manually. Sometimes it doesn't refresh automatically. Import what is the total thing? Let's see any other import. Where should I start? Okay, so import, I don't think we can do this, but let me try. Import, where is this actually? Okay, let me find out its path. Okay, so the path is total this. I can start from here. It actually hung when I typed dot. It hangs. We should not have moved it. Okay, anyway, since we have moved it, we have to go all the way. Okay, so I think my Eclipse is hung up because of this dot. Okay, so what I'm gonna do is I'm gonna restart. I think it's not responding. Okay, there we go. It's not responding. Okay, let's wait for a minute and see. Okay, finally. So I should not have typed the dot when dot means it's accessing. Come on, I don't type the dot. Okay, if this doesn't work, then I'll move back the interface. Yeah, unfortunately, it has to be in the same package, I guess, or I tried to import, but it's not working. Okay, no issue. So this is just a demo. So if you want to keep both in the library, you can keep it. Unfortunately, I cannot keep interface in library and then the implementing class in other test. It should work, but it's not. Okay, anyway, let me move it back. So you try that. That is just simple, this thing. Different, keeping the classes interface in different packages.
So we can just do the test, right? We don't need to do the demo, right? You mean?
You can put, if you want put both in library, you can put so. Unfortunately, it's not allowing you to put interface in one package and the class implementing this interface in another package. It should work, but let's not go about it. It's a simple thing. Let's concentrate on the concept instead of package thing.
Okay.
You
So
can,
what we're doing in the interface actually?
okay, so that's a basic question I explained right now. So what do you think an interface? Let's go back.
Yeah.
Oh my god, I copied. Okay, I should have moved it. Okay, let me delete it. Did I copy it? Interface main calc. Okay. Okay, so let me delete it. Okay, so meanwhile you can answer that question. What is an interface? I just explained in the beginning. That's what I explained. Okay.
Okay, is this the interface is a class, but it's not a class, but you can write a method and
Back to final. Okay, yes, go on.
and I'm not sure about the abstract. Is belongs to the abstract or and yeah.
So I guess okay. So you're having doubts, right? Okay, I'll give you one more example. Think of interface as a building. Okay, building that is newly built, newly constructed. Okay.
Yeah.
So how would it be? It would just have some empty rooms, correct? Now they are giving this empty building to lease. I mean, leasing this empty building to an office. Okay, so what they will do, let's say office, let's say some XYZ, they will actually order some. Whoever wants to do the, I mean, furniture thing, interior decoration, all these things according to their need, they will put the furniture, tables, desks, whatever is required for the office. Okay, so that means they are implementing according to their needs. Okay, so the empty building, you think of the empty building as the interface, and the class which is implementing this building as the office. Make sense?
Yes.
Simple as it. Do not complicate it. If you complicate it, you can find out the complex definitions. That's all different. Try to understand this concept, because that's what we are going to use in the automation also. I mean, Selenium driver. Okay. So what in this interface, what I'm creating, simple abstract methods. What are those? The methods which have only declarations, but no definition.
No
Okay.
definition.
No definition. So okay, why I'm saying normally in the library, what we have created so far, let's say for example, arithmetic demo. In arithmetic demo, what I did so far, I created some functions, reusable functions or reusable methods. What are those? What does it mean by reusable methods? The methods which have definitions and can be called, can be used multiple times. Okay, that's what it means, right? Addition. Okay, now if I want to call this, if I want to create an addition, reusable function called addition, I would create something like this. It's not necessarily has to be similar, but it is something like this. So I want to add two numbers, so integer a, integer b, then I would add them and assign it to integer c, then I'll return simply integer addition of these two numbers. I don't have to return, I'll just put void and remove this return statement. It's all up to me. Okay, so I can do whatever I want to do, or according to the requirement, right? So this is a proper reusable function. Now what is abstract? Abstract is, it doesn't have, you can make it concrete, okay, by implementing. In the implementation I would make this contract, but these methods are abstract because these are vague. Okay, I just want to add, I just created the name, the function name is add, but what do you want to add, how do you want to add, what do you want to return, that's up to you. Up to what? Up to the class which is implementing this interface. Okay, so that's why I just created abstract methods. Abstract methods are to be created in the interface, because I don't want to create a specific concrete method here, so that whichever class wants to implement it, they can implement it according to their needs. Okay, let's say I created a class called in scientific calc. In that add, I just printed this, right? You got it, right? Now I'll create one more class. I'll define it little differently. I can define it actually. Let's say I will actually accept two arguments, and I will add those arguments, add those integers or doubles, and then print the add. Okay, so that would be my new definition. I can redefine it in any other way, 1,000 ways, million ways. Okay, so but in the interface, I am just creating abstract method. Hey, this is a method. Okay, now take it and implement it in whichever you want, whichever way you want to. Okay, that's exactly the same as definition I gave you. Empty building. Okay, then you can give it to XYZ or ABC. Now they will do whatever they want to do with it. Okay, so they will they will furnish it according to their needs. You don't have to necessarily furnish it in a specific way, right? So that's up to, that means it is totally generic. It's up to you. You can implement it in whichever way you want to do it. Okay, so let's not go about it repeatedly, because if I keep on explaining, it will go on, I will go on and on. Okay, so now what did I do? Yeah, so these implemented whatever are implemented, those are being called, correct, using two types of objects, cal and cal2. So cal is simple object of scientific cal, which is actually class, and other is instantiated like this: main calc object is equal to new the class which is implementing it. Correct. Now we have seen already this is called. Now I want to, using cal2, I want to call multiplication. Where is mul? Mul is in the class which is implementing. Okay, not, it is not there in the abstract, is it? It is not there. I did not create mul. So what happens when you want to access it, it will throw the error. Okay, so right away you cannot do it because it's not, the abstract method called mul does not exist in the interface. That's why you cannot do it. So cannot access the implementing class method direct. So that's a illegal operation. Okay, now let's see the practical aspect of it which you are going to use it. So for example, in Selenium means right now Selenium WebDriver, right? And I will give you more introduction about it later. But WebDriver itself is an interface. Okay, WebDriver is just like an interface. The interface that I created, interface main calc, it is an interface. Okay, I don't have to create it. I'll just download it as in terms of jar or dependency. Okay, now it has all the classes, all the methods. Okay, what are those methods? Abstract methods, something like this. Okay, this is one of those methods actually. So I'll take it down here and stop. Okay, let's put it here. Okay, so this is one of those methods. One is public void get. Okay, so this will take string URL, whatever, right? So then what it's supposed to do, get means it is okay, sorry, not in quotes. Okay, get is supposed to launch the browser and open the URL. So that's what it's supposed to do. But in this case, let's imagine this is in the WebDriver interface. Okay, not in this particular interface. WebDriver interface. You don't have to create the interface for WebDriver, it's already available. Okay, so let's wait again. It is building again and again. Okay, great. Okay, so there will be methods like this, many methods which we are going to use them directly. Say public void send keys, something like this. Okay, so this will accept string again, string input, something like this. So all the WebDriver interface will have all these abstract methods like this. Okay, now if I want to open the browser, okay, so I have to actually define it according to the browser's customizations, right? So now what let's say Firefox will do is, Firefox actually takes that get, okay, implements it. Okay, implement in the sense public void get string URL and then provide the definition. What do you want to do with this? It will be to do. Okay, so it could be anything, blah blah blah. So that is up to the Firefox. Now if I want to actually call this, I will actually call using the driver. So driver dot get will I will be able to access this get using this driver. So interface object equals to new the class which is implementing interface. So this is similar to this one. So this is what is going to be used similarly. For example, Firefox has defined it in according to the Firefox configuration. So now I want to actually run my automation in Chrome, let's say. Now what you have to do is WebDriver driver, let's say driver2 equals to new Chrome driver. Okay, you don't have to implement or you don't have to create this interface, we are just using it. Okay, Chrome driver, and using this driver2 I can call other function, because that function would be implemented in the Chrome driver, which is the class which is implementing the WebDriver interface. So it would look like this. Let's say in the Chrome driver it will have public void click, let's say, right? So all that, how to click, to do. We don't know how to click. All the information, necessary information on how to click on the given X path, it will be provided. Okay, you can check the source code, but that's not our concern actually. So okay, so this is all we are going to see soon. So I'll just comment it. Okay. Okay, so now cal 2.x, so whatever the x value, it will print. So x value is already given in the interface, so automatically it will print, so no problem. X is equal to 10, it will print. Okay, so that's just, this is just an introduction. Don't if you want to go more into the interfaces, you can learn more about, but it's not really required. Just for the automation, I gave you introduction. Okay, so I guess that's the overall Java that we need. I don't have any other. If I miss anything, you can remind me. What I did was I actually imported this Java tutorial. Okay, so I guess I sent the link in the last class. I will also send the link today. Okay, and actually it would look like this in the Google Drive. I put it, correct? So when I exported, it saved something like this. It's zip file. Okay, let me show you again. So this is the zip file. Okay, Java tutorial. So what you are going to do is just import it. Okay, so there will be option called import, and import the zip file using this existing projects into workspace or archive file. Sorry, archive file. It would import it, and you will get something like this, so that you can practice, or you can explore more, or you can go through the existing one. Okay, so that would give you more about this. That just for the Java. Okay, but since we are planning to use Java, not just becoming Java expert, Java developers, so the main plan is to code the automation test scripts in Java. So that's why the core Java knowledge will be useful, but you can explore more on this. It's easy. You can go on internet and explore more, or I'll give you more example if you want. And in fact, I have already given you more example.